Check, check.
Hello.
Hello. You look like you're getting ready to put on the show, so don't let me distract you too much.
Okay.
But I am, I think, the last speaker for the lightning talk. I have a few slides. What's the best way for me? Can I just like go up and
Yeah. So
use
there's
an HDMI port?
there's a USB-C cable on the podium there.
Okay.
You can just connect to that, connect your laptop with that, and then that'll show on the screen.
Okay, so this works.
Great.
Check, check, check.
Hi.
Said it works.
Okay, great.
Yeah.
Thanks.
Hey, you were able to make it. So
Do you have any slides? Yeah. So I want to make sure you.
yeah. Yeah. We'll switch to computers.
You know, it keeps going to need access to my slides. I gotta find out who I am. Well, that's what
Okay, but I can connect to my phone.
For whatever reason, no, we'll figure it out. For whatever reason, I'm connected already, but I'm connected to like a public.
Oh, so
well, we'll get this.
you know what I can do is I can share slides with you. You don't have to. So is this your computer that you use all the switches? Yeah. Or we don't have to. And you would put it on the presenter format.
That's why I keep thinking it's just all over. Let's just test to see if yours works.
Yeah.
That way you have control over your.
I don't mind either way.
Yeah.
I'll share it with you anyway. So what's your name?
All right. And I can know.
And
SEN. It's different. Hey, how are you? Nice to see you. Yes. I'm trying to find where is the option from the same thing with the mirror display here in the back. It's weird. I'm not seeing it. Oh, okay. You're not using favorites, but okay, yeah. Stop mirroring. Okay. So now just want to make sure that I set it up correctly. That I don't have to do that. So yeah, I have it now. Okay. Yeah, yeah.
Absolutely. I'm going to read it. But it's also because you're trying No, it's just a personal thing. The most common thing, is the bearing display. Yeah, with the you go to present, and it just trigger. So you can see here, that means it's sweet.
So should I?
So I think you're good.
I'm good. So that's what doesn't have anything. You will?
Yeah. I go and rotate, and it rotates to this one.
Oh, okay. So
I don't know. For some reason, it showed up for me. It took a while.
oh,
I think you're good. I mean, try that.
okay. So it's good, right?
Yeah, it shows up down here, not up there, but I think that's because you, yeah.
It shows up here. He's gonna basically technician. He's got screens. Yeah. Oh, see.
Oh, yeah, no, actually. So all I have to do is just. Yeah. Oh, but, so I didn't check. Since we switched to passkeys, like authentication on this machine is a whole thing. Yeah, no, it's working. We're good.
Yeah, I'm in oh, okay. So I'm going to be at the Sept. Yeah, thank you. Okay. So here, I'll take this one away. It should
Double
just
dot
plug in.
multiplied to
The thing
5%.
that throws people off sometimes is the mirroring.
Yeah,
Mirroring
yeah.
stuff.
Shall I?
And it's been showing up here for people, but not up here. But okay, there you go.
Oh, you don't want it to mirror?
Yeah, I
Okay,
don't
all right.
First time two presenters together.
So I'm gonna start. I think so. I think you guys are Yes.
Okay, great.
Sorry? Yeah, that is the edge, yeah. That AutoCAD is not part of it.
Okay. Okay, yeah, here, I have it.
Yeah, we should get going.
So we're gonna double mic you guys. You're also gonna say some words?
Yes.
Okay, so we'll put this guy right here.
This is the DJI thing?
Yes, so these are just for the camera, and you guys are gonna use these handhelds to talk to. Right. So,
I should
You don't-
remember
you
to
don't
take this
have
off,
to-
otherwise gonna be
Yeah, I'll-
recording everything I say.
well, I'll come and grab it for the next week.
Okay. I had that incident once.
Oh, yeah.
I went to the bathroom with it.
Two.
because there's actually going to be like a few people before.
Okay.
Yeah.
Oh, before?
Yeah,
Oh, I'm
because
sorry.
because it's a little complicated. The Zilla's guy.
So we just pass it around.
It's going to go
Sure.
first.
Would you do that?
Yeah.
Okay.
Why don't I take it? I'll give it to you.
Okay.
Then I'm gonna go. I'll introduce Anthony, and then he'll come back to me.
Why don't you just, you're in charge of this? Or?
Yeah, why don't I do that?
Yeah.
Yeah,
Because you stay here the whole time. So.
pretty much.
Okay,
Yeah.
yeah.
And I'll make sure you get it.
Okay, it's just got a little clippy. It's like a shirt like this, so
Yeah.
just stick it right there.
Okay, so Anthony is able to come over and do the ALI?
Yep, yep.
Cool.
Yeah.
Okay, very good.
Towards your mouth. I'll just leave this other one up here so that.
All right, all right. So we are getting started in a minute. So for everybody in the back, if you can come ahead and grab a seat, please do so quickly, and we will have a good party going on in a few seconds. Okay, so let me do a quick poll. How many people have been in Unstructured Data Meetup before? Whoa, we see some old good friends, and welcome all the new friends. So my name is Jiang Chen. I'm the head of ecosystem and developer relationships at Zilliz. Zilliz is the company behind the popular open source vector database called Milvus. So we have been, yes.
Record you. Double click.
Oh. Do I need to hold this as well?
Do both.
Okay. So we have been starting this unstructured database, unstructured data meetup for over a year already. And as you can see here, we are hosting the events with our great community members in many cities across the world. And San Francisco is always a hub for generative AI. And it's always excited to be here and see our users in the open source Milvus community, the generative AI startups, the founders, and all the developer friends. So we hope you enjoy the event, as well as learning the new trends and all the interesting topic happening in this space, because there are just so many things happening in that. And there's a say that, well, a day in generative AI is a year in the human beings world reality. But well, to some extent it is, right? There are just so many things happening. So a little bit about ourselves. we created Milvus, the open source vector database, a few years ago. And it has been pretty popular among the developers. Right now we have 29K plus stars, and there are over 80 million downloads. So Milvus is the highly performant vector database for storing, indexing, and managing the vector data, which is generated by the embedding models. And over time, this has been the core piece of the information retrieval stack in the age of AI. And it has been widely used in many applications, such as chatbots powered by retrieval augmented generation and multimodal search, so that you can have text to instruct the image, and then you can search image not only based on the original image, but the instructions applied on top of that. So there are many, many interesting use cases that we're seeing. And also we have seen the widely adoption, the growing adoption of vector search and this whole stack in a lot of verticals. And today we'll have a lot of great topics in that as well. And speaking of the landscape of generative AIs, nothing about one single piece. It's actually a composition of many technologies, from the AI hardware, like the advancement in GPU, the computing power, to the kind of a democracy of the machine learning models, which has been only kind of widely utilized by the large enterprises or large web giants. And now there are more and more developers who can have access to embedding models and large language models, so that those things only available to teams with, say, 100 people infrastructure team is now available to a one-person shop, which is really doing innovative work in the entrepreneurial world. And also, speaking of data, data is a very complex stack of systems. It contains we are building vector databases, so we always say, you need something to store and search, but there's more than that. To really have a production-ready data stack, you need data cleanup, data ingestion, like data ETL. You also need security if you want to apply it to a kind of enterprise setting, or if you have a lot of users and you want to control the access and have really provide safety and privacy to the users. And to build those, you need data pipelines, like all sorts of frameworks and infrastructure pieces to develop the data pipelines. And once you have the pipeline, you need observability to know the health of it, to have continuous monitoring of the data pipeline, which is really powering your the engine behind your business. And of course, if you are working in industries like finance and public public sectors, you need great data compliance as well. So as a company focused on vector database, we want to foster a community where we have the developers and entrepreneurs and all of the friends to come together and share the topics, share the learnings in this great journey. And we want to eventually foster an innovation in this Gen AI space, because it's so exciting. And also we would like to encourage collaboration between you, so that if you are looking for a co-founder, or you are trying to hire your first engineering employee, we would also like to provide a space so that you can share the information, and we can have the community to help you. And also, we always want to encourage transparency. So if there's any feedback, please feel free to raise that to us, so that we can do better next time. So so here on the left, that's the QR code for the open source Milvus project. So we'll have a raffle at the end of this unstructured data meetup, so that if you can kindly visit our page, GitHub repo page, and give us a star, you will automatically enter the raffle. And we hope you can win the great prize, which is a bunch of Milvus swag. Who doesn't like swags? Okay, so And also, Milvus, the open source Milvus project is actually one of the member of AI Alliance who co-hosts this event with us today here. So before I really kick off the party, can I really have a short piece of freestyle? Is anyone objecting that? Okay, I see no objections. Okay, Unstructured Data Meetup by Zilis. Creator of open source Milvus, vastly scalable and high performance, reliable vector search even with billions. GenAI is boring without community members. Together we thrive in AI Alliance. Well, welcome Dave to the stage from AI Alliance. Dave.
Thank you. That's pretty impressive. Back in my college days, maybe I'd throw down some tile and start spinning. No, I wouldn't do that. All right. Thank you very much, Young. That was really fun to follow. My name is Dave Nielsen. I am new to the AI Alliance by about 2 months, so it doesn't make me too new. But I'm really excited to be here and be in front of you just for a few minutes, just to set the stage and MC the rest of the evening. I'm going to just share with you a few things about the AI Alliance. How many of you have actually heard about the AI Alliance before this event? Raise your hand. Okay, maybe about a quarter of you. That's great. Okay, well, that's what we're trying to do is spread the word. And I'm just going to share a few things about the AI Alliance. First of all, what are we? Well, we were formed around the idea of open models. Okay. Both IBM and Meta have a big interest in making sure that everyone has access to models, that there's not just one or two companies running away with the show. And so open source is a great way and able to involve lots of different companies. And so our goal is to do as it says on the screen here, but I really want to focus on when you're building models or using models that you're using them in a way that's safe, secure, and trustworthy. All right, because that's what large companies who want to use generative AI, they need that in order to be able to use the technology in their solutions. Okay, and so that's really what we're about. But it's not just big companies, it's also small companies who also want to, startups that want to collaborate with the community. And you can follow us if you like on Twitter. It's @thealliance_AI. We're now at over 120 companies, and most of them are large, but like I said, there's some smaller startups in there as well. Names that you would know, like Hugging Face and LangChain and Llama Index, etc. And so we've got a lot of different companies. Olama is going to be hopefully joining soon. I just was talking with them. Anyway, there's a lot of interesting companies, but there's also big companies. Meta, of course, and all what they've been up to. And IBM, we have our own model called Granite. And of course, companies like Zilla's and Neo4j, some vector database companies. There's a bunch of companies. There's also research organizations, universities, Ivy League schools all over the world, not just the US, all interested in research and collaborating with each other. So there's going to be a lot going on. We're fairly new, but we're just getting ramped up. So please keep an eye on what we're up to, and hopefully we'll find something to share with you in the near future that you'll find interesting. The different areas, just real quick, that we are focused on are education, like I said before, trust and safety, applications and tools. This is basically all the different open source projects generally that you will need in order to build models, clean up your data, all that kind of thing. Hardware enablement, that means helping models and hardware to work together, so you have a choice. And of course, the foundation models, there's a lot of interesting work going on there. There's as you know, there's very few very large successful open source models, but there's really going to be a long tail of models that are focused on different areas, and we're seeing a lot of activity there. And then advocacy. We recently ran a open source AI demo night over here at Shack 15, where we showed off all the different open source entrepreneurs using open source, because there's some legislature in California going through the government right now that could have an impact on your ability to use some open source. If you want to see some of the projects we have going on, we have an open repo at the AI-Alliance. Go check us out on GitHub. And one such project that is really, really early stage, but I wanted to share with you because I think it applies to all of our members and perhaps you as well. Once you get to the point where you've built an application that is using a model and you need large amounts of data, sometimes it can cost you just as much money to clean up your data as it takes to actually use the data, or I'm sorry, train your model or fine tune a model. It can be very expensive to clean up your data. And so we have a project that we're working on right now. It's with IBM, but it is going to be an affiliated and possibly core project within the Alliance. And it's basically a bunch of modules that you can use in a pipeline to send through and clean up your data. So if you want to look for privacy information or perhaps harmful language or code, or if you want to simply dedupe your data, that kind of thing, this is not only meant to do all of those things in open source modules, but also to do it at scale. And right now, you can scale it out on Ray. And we're also working on doing that with Databricks. So this is a project that we have a workshop coming up. If you want to find out more about it, we actually have a hands-on workshop. We're partnering with Zilliz with their open source project called Milvis, and basically showing you how you can take data that's you're just pulling off of a website or from I don't know, S3 bucket or something, and put it through the pipeline and then put it into a vector database, and then you can then have a like a chatbot or some other application using that data. And that's on September 21st down in Mountain View. So back to the Alliance, we have lots and lots of working groups. There's probably something for you there. So if you're interested, or maybe your company is interested in joining, you can go to our website. If you go to thealliance.ai/community and go click on the collaborate section, you'll get to a page where it shows all those different options. Okay, and there's going to be a lot going on. Again, we're just getting started. This week alone, we are sponsoring 4 events in the Bay Area, and we do them around the world too, but the Bay Area is where we have the critical mass right now. And so those are events, of course, this one, and then tomorrow we're at the AI conference just over at Pier 27, I believe. And then on Wednesday down in San Jose, there's an AI summit. It's associated with Intel, but we're sponsoring that event as well. And then on Thursday, there's another event back up here, Alexi's event. And where is that, Alexi? Where will that be? Right here. Of course, right here. Where else would you be, right? Okay, so thanks. And yeah, so with that, I think I'm done with my part of the talk here. But I just wanted very quick, did I miss anything? Is there anything that you guys have, like some obvious question that you have that I can answer real quick? Is there anything that you have about the AI Alliance? Okay, now also is Anthony here. Oh, you have a quick question? Yeah. You mean tonight? In general. Oh, okay, yeah. So the AI Alliance is definitely cuts across. So the question was, is the AI Alliance generally for like AI engineers, or is it for a broader spectrum of professions? And it's definitely for a broader spectrum of professions. Especially when you think about things like, well, like trust and safety, all that kind of thing. That definitely cuts across a lot more than just engineers. In fact, I would argue that here in Silicon Valley, we really don't think about trust and safety early on, do we? So it's something that is very important, however. So, but it's not just that; it's education. It is how product market fit sometimes, because we have like this open source project. We're definitely looking at how it fits into the market right now. So I think there's a lot to benefit by participating. And really, once you join, you can get into our forums and have conversations and really get out of it what you need. Yeah. But definitely more on the professional side of things. Yeah. Okay. With that, is Anthony here? I don't think Anthony has made it back yet. Okay. So I'll just all I'll say on Anthony's, he's my boss. So obviously want to give him a shout out if I can. But the AI Alliance was founded initially by IBM and Meta. And it's a really interesting combination of companies, as you can imagine. Meta is just blowing the doors off open source large language models, and really in an incredibly impressive way. And IBM has a lot of history working with large companies and governments. And so if you can imagine how difficult it would be to take something like generative AI and get that into the industry, it's not easy, especially when you have things like hallucinations going on, right? So together, though, we've got such an interesting combination of companies that are really working hard to solve a lot of the problems that are serious if you want to use this technology in mission critical ways. Yeah, I just say that, and Anthony, I've been working with him only for 2 months now, but like we're really pushing barriers that large companies face every day, and we have a lot of people working on these challenges. And so keep an eye on us, because you're going to see a lot of things happen. All right, so with that, let's move on to our talks. So our first speakers, I say speakers because we have two, is Christopher and Shruti. So Christopher Nguyen from AI Aitomatic. So it's automatic, but AI at the beginning. Come on up. All right. And I'm going to give you the mic. Oh, okay. Oh, good idea. Yeah. All right, we're innovating on the fly here with double mics on the microphone. Very good. Thank you. All right, so I'm going to turn it away. I will just, by way of introduction, share that. Go ahead and connect. That they are just off of running a very successful industry AI conference at the Stanford Faculty Club on the Stanford campus, followed by a very interesting, to say the least, dinner up in the hills above Silicon Valley. If you get a chance to go to one of their events, they put on a very effective and interesting show. So thank you for that. Thank you for being here.
All right, thank you, Dave. Hi, everyone. My name is Christopher Nguyen. In one capacity, I am the CEO of a company called, Aitomatic, as Dave said. And we do something called industrial AI. And so in preparing for this talk, I've decided either everybody's going to fall asleep or leave or become really, really engaged, because Silicon Valley does not work on industrials, correct? How many people here have anything to do with the industrial AI? See what I mean? Okay, let me try to engage you a little bit. How many people have physics background? Okay. How many people know that the US, we are trying to re-industrialize? Okay. And how many of you know that the salaries of packaging engineer in semiconductor industry literally tripled in the last year? Okay, that's quite interesting. So, and the reason I do industrial AI, is that already showing? Yeah. So my background, one of the things you can connect to is that I helped launch Google Gmail, Google Apps for the enterprise market back in the mid-2000s. But few people know that actually I did my PhD in semiconductors. So I'm actually an expert in the topic that we're about to talk to you about. And the reason we do this, and by the way, coming back to the AI Alliance, and I'm a lead on the foundation. You saw that there are 6 areas, the foundation models effort. I'm a co-lead of that. The AI Alliance, we're very much output oriented, right? You know, when I help organize this together with Anthony, I said, well, I don't want to join something where just a bunch of people get together and say nice things about the world and each other. There's too many of those. So it has to be very action oriented. We want to have outputs right away. And SemiKong, which is a topic of this, SemiKong stands for, in this case, for a foundation model for semiconductor. right? If you are not already savvy about this, you will see that over the next 6 to 12 months, there's going to be a lot more differentiation between generic models, right? Llama, Gemini, even OpenAI, GPT, and so on, and domain-specific models. And I won't have time to talk about the motivation for domain-specific models. But this is something that is very important to industries, particularly the physical industry. And as Dave said earlier, right, AI Alliance, we want to have consequences. We want to have impact. And so we engage, in my case, for example, my previous company was acquired by Panasonic. So I spent 5 years running industry AI, global industry AI in Japan. So we have a lot of Japanese members of the AI Alliance that are interested not just in the software aspect of AI, but also how to apply it to their industries, specifically refrigeration, automotive, avionics, semiconductors, and so on. So today, we're going to share with you the applications that have been built on top of this SemiKong model. Okay, so with that, I'm going to hand it over to Ving. Are you doing this or am I? Okay, all right. So, okay, so this is Shruti. Maybe introduce yourself, and then we will, go back and forth.
Sounds good. Hi, I'm Shruti. I'm an AI engineer from Aitomatic. And today we're very excited to introduce to you SemiKong. It's one of the first domain-specific models. It's built specifically for the semiconductor manufacturing industry. It's open source and is powered by Llama 3. So as Christopher mentioned earlier, the semiconductor industry has been facing an exponential growth. The US is set to triple its semiconductor manufacturing capacity by 2032, and Japan has invested $25 billion in just the last 3 years alone. So, but the industry faces a critical challenge. The semiconductor manufacturing industry relies heavily on its experts, who are specialists with over 20 years of experience. And these experts are currently in critical short supply, which makes it crucial for these industries to be able to capture and scale their domain expertise. And that is exactly where Aitomatic's AI agents and SemiKong come into the picture.
So in this context, I am the domain expert. And as Shruti mentions, it turns out, and if you think about foundation models today, in order to make them actually useful at a level where they can actually solve problems, right, beyond just question and answer, in an industry like, say, semiconductor, let's take an etcher, right, RIE, reductive ion etcher. You may ask GPT-4, how to do something, and it's going to give you a whole bunch of answers that look very advanced. But think of it as a fresh PhD kind of level of knowledge. A lot of text that comes out, but it actually doesn't have the experience, right, of someone that's been in the industry working on that particular piece of equipment for 20 years. And so that is the kind of expertise that we need to encode, not just in the model, but also in the systems that surround it. So Shruti is going to show us an application that has both the deep knowledge of SemiKong for a semiconductor, but also the application above it that has some very equipment-specific knowledge that has somehow been injected for the purpose of that particular piece of equipment.
So let's imagine that I'm not an AI engineer, but a semiconductor etching process engineer. And my team and I are facing a problem, a very specific problem that requires a lot of expert knowledge, both specific to semiconductor manufacturing and specific to my company to solve it. So let me pose this to our agent here and then ask and see what it has to say. So, okay. So now let me come back and give you more context. So let's say I work at a leading fabrication company where we've taken on a contract to build the next generation of 3D stacked chips. My team and I have been working 16-hour days for the past 2 weeks, but we're nowhere close to achieving the necessary smoothness of a silicon surface that we need to achieve the target requirements of our contract. But why is this? Semiconductor manufacturing is an incredibly challenging process. It requires a deep knowledge of the physical and chemical interactions involved. It requires extreme precision and cutting-edge technology. We're manipulating materials on an atomic scale. Typically, my team and I would spend hours on analysis or wait until we have access to an expert in my company to help solve this problem. But today, we have with us an etching advisor from Aitomatic. This is an AI, domain-specific AI agent that's built on top of SemiKong. So,
So essentially, it's a version of me. What we have here is a process called chemical mechanical polishing. So what you see on the screen is what's a wafer, right? That's where IC chips are made. And by the way, as you think about this demo, I want you to note the unusual aspect. Again, when you apply this to the industry, after we announced SemiKong at SemiKon West at the Moscone, that was just in July, the whole industry lit up. Jensen Huang was interested, right? And sort of told his team to go find out what was going on. Applied Materials, Tokyo Electron, these are names that you may not be familiar with. Certainly, you know TSMC, Samsung, all want to apply this. And it turns out company that we've been working with, Tokyo Electron, has been working with us on this for over a year and a half. So what you're seeing here are things that are actually in field testing. It's not some abstract thing that with a demo that we just put on here. So the CMP on the left-hand side, what you can see is a wafer. The fact that you can see a rainbow on it, right? Essentially what you're seeing refraction of light coming, hitting the wafer surface and then bouncing back out. And the fact that you're seeing a rainbow means that the thickness of the film on top of it is non-uniform. If it were uniform, you wouldn't see a rainbow, correct? And so the goal is to polish it down in such a way that, of course, you can have much more sophisticated measurements, obviously, but just a human eye can just look at that and say, well, there's non-uniformity on that wafer. And so Shruti is gonna, pretend to be a fresh PhD engineer, and she has knowledge about the process, but does not have enough experience about, what are parameters, how do I tune the knobs, and so on, just to get the recipe that I want. And by the way, one more thing that I would stress is that most of us think about semiconductor processing as a very precise engineering effort, which it is, but is extremely, extremely human expertise dependent, right? And hard work. And so this is essentially the heavy lifting of that expert labor is being offloaded to this application.
So as you can see here, this AI agent, the etching advisor, as I will call it, has given me a detailed and comprehensive response. It mentions multiple approaches like wet chemical etching, chemical mechanical polishing, and dry chemical etching. And it gives me the pros and cons of each process, and it gives me a set of evaluation criteria that enables me to choose one process from these. This is because SemiKong has been fine-tuned on data that is specific to semiconductor manufacturing, textbooks, articles, research papers, and industry best practices. It's powered by Llama 3, but it has been but this fine-tuning allows the solutions that it generates to be able to be informed by knowledge that's specific to semiconductor manufacturing. So now let me try to leverage this agent to actually develop a solution for the problem that my team is facing. So I will ask it to recommend a detailed procedure for me to actually perform the chemical mechanical polishing approach that it has mentioned. Thank you. So another important aspect, as Christopher mentioned, is that semiconductor manufacturing is very expert specific. So there are several facts and rules of thumb that experts in my company use to solve problems that are specific to our company. For example, we have custom made equipment for chemical mechanical polishing, and we have very specific process parameters that work for those. And our experts use this information while coming up with solutions for us. But Aitomatic system has a way to capture these from our company into its AI agent so that its AI agent can leverage these while coming up with a solution. So let's take a look at how this, an example of this. So as you can see here, these are some facts and parameters that are specific to our company's manufacturing, our company's proprietary way of performing this process, which I've encoded here. And if you compare this with the answer that SemiKong, that this etching advisor has come up with, you will see that it follows this almost word to word. So it uses these specific parameters to come up with this customized solution for my company that I can use directly with our proprietary manufacturing techniques. So let me go ahead and ask it one last question, which will help me come up with a complete solution to the problem that my team is facing.
And by the way, I stress again that you're seeing an application that has a neurosymbolic engine on top of a model, and that's how it can reason and it can plan through what is the right recipe. This is actually like cooking. So what Shruti is asking for a recommended recipe for the process.
The other dimension along which Aitomatic's framework captures knowledge is expert plans. So the experts in semiconductor manufacturing, or imaginably any other industry, have specific ways in which they think through and solve problems. And this information has not been coded anywhere. It's all in their heads that they've developed it through years of experiential experience. Aitomatic has expert plans that can unlock and codify this information in a language that AI can understand and replicate. So let me show you the expert plan that supports this CMP process. So here is an example of the way or the roadmap that an expert would use to come up with a solution for chemical mechanical processing. So once again, if we go back, we see that these are the very steps that this AI agent has used while recommending a recipe for me. So first, it performs pre-wafer cleaning and preparation, which is step 1 here. Step 2 is CMP slurry selection and preparation, which is the next step here, and so on and so forth. So Aitomatic's framework has another distinctive capability, which is planning and reasoning. So every task, every problem that this system solves leverages something called hierarchical task planning and OODA reasoning. What this means is when we present this agent with a complex problem, such as recommending a procedure for chemical mechanical polishing, it breaks that problem into a set of hierarchically organized subtasks, like the one shown here. This allows it to have dynamic decision-making capabilities, and it improves performance in tasks in which precision is very important. And each subtask is executed through an OODA reasoning loop, which stands for observe, orient, decide, and act. So this allows us to execute these subtasks dynamically and adjust on the fly for optimal decision making.
In fact, what you see, a lot of this is human expert knowledge, right? And we're here at the Unstructured Meetup. I would like to motivate you to think about adding a name or even changing, it's actually calling it unstructured data kind of cheapens it. It's actually knowledge, right? We go through a decade of machine learning, distilling data and so on, and putting them through algorithms to extract insight. But now, for the first time, we can process expert knowledge directly, right? We don't have time to show you the demo, but we have tools and so on that can interview aging experts that are leaving companies, and so on. They can leave really many millions of dollars worth of knowledge that have been built over the years that are not written down anywhere. And what you're seeing here, the plans, all those things actually came from them, right? And in industrials, we do not want creativity. How many people here have come to that stage? You've gone past the kiddie stage with LLMs, and now you're working with customers and they say, I do not want probabilistic behavior, right? Right? So that's why you need this deterministic behavior that can come only outside the LLM. Of course, a lot of people are trying to work and fix the problem, somewhat, with some vain effort in trying to fix it within the LLM, but we firmly believe the solution is actually outside of that. We open source this framework for that already. It's something called OpenSSA. The S is called Small Specialist Agents. We apply it primarily to industrial problems, but I don't see any reasons why you can't apply it to your digital problems, right? And we have the owner of that project, Ving, sitting in the audience here. As far as the SemiKong model, we did that work as part of what I said earlier. We want the AI Alliance to have concrete output. And so SemiKong was conceived, worked on as a result of collaboration among 3 companies: Aitomatic, Tokyo Electron. If you're not familiar with Tokyo Electron, think of them as Applied Materials down in Santa Clara. They're competitors with each other. And FPT. It would not be possible without the AI Alliance, right? Because companies don't naturally share expertise and resources in this manner. And so the SemiKong effort was done, conceived, executed, and released, within months of the creation of the AI Alliance. Anything else? Okay, with that, so just remember OpenSSA. Of course, we're going to open the floor up for questions. Ving is here to answer the question about the application layer, and Shruti is going to, essentially can field your questions about SemiKong, the model as well. So we're going to, yeah, one question.
Application cost like $3 million. If that they use your product, like how much cost you can save for?
Oh, okay. So the question is, what's your name? AT. Okay. AT said that the Apple M1 chip cost $8 billion to develop. The application cost, fab cost. That sounds very low, actually. Yeah, maybe for one batch, $8 billion. If relative to $8 billion, if they use this, how much would it be reduced by? If I give you the full answer to that, I have to think through the logic of it. I won't give you a quick one, but essentially, a lot of the cost of the loss of expertise is amortized over time. How many of you know that TSMC actually has started to build in Phoenix, Arizona? Right. How many of you know that TSMC has also started building around the same time in Kyushu, Japan, which is outside Taiwan? Okay. How many of you know that in real time, the project in Phoenix is failing? And the one in Kyushu, Japan is succeeding wildly. Same technology, same cash, this is the same company. So it's a very interesting experiment in history that we can see. What's the difference? Yes, yes, exactly. And you don't have to just believe me. You can. It's now public knowledge. You can read about it. So that would be my answer to you. Without the expertise, I don't think the dollars, $8 billion can be, this, it's 8 billion down to say 4 billion. I think it's the inability to do it at all, right? So I think strategically the US, we're trying to, when Mark Andreessen says, let's build again, this is let's build again. We're not bringing back low cost manufacturing when we say let's build again. So I think we have to address the challenges that we have. So I would say, with this, it's the difference between being able to do it versus not being able to do it at all. I think that's the enormous cost. Okay, with that, I'm going to hand the mic over to Mike.
Great. Thank you very much, Christopher and Shruti. Thank you. Okay, what stuck out of my mind in that is I can just imagine somebody who's been working in a industrial company for their entire career, and they're getting ready to do their exit interview. And the company says, we'd like you to take all of your knowledge and share it. And he goes, let's see, how much can I charge them for this? I can just imagine somebody just sitting down and charging a lot of money, like retirement-like money, for that person to share their knowledge with the company that they've been working for all these years, but he's earned it, right? Or she's earned it. So that's interesting. I like to see those opposite of Black Mirror examples, right? The ones that have the positive outcomes. All right, so our next speaker, thank you. I'm sorry, come on up here. We got Zhuo Li, the CEO of Hyrdox AI. I had the pleasure, go ahead and set up your laptop here. I had the pleasure of visiting them over in their offices down in Silicon Valley, and they're a small, nimble, exciting company. And I'm gonna let Zhuo take it over from here. Thank you. Thank you.
Hi, everyone. My name is Zhuo. I'm the founder and CEO of a company called Hyrdox AI. This company works on AI safety and security. So basically, we empower AI safety and we build safe AI. So today, I'm going to talk about safety evaluation of LLMs in the high-stake domains. So I think everyone, at least you heard about safety evaluation. Probably you checked out a bunch of the leaderboard, dashboard, benchmarks, so on and so forth. But probably those only apply on the SOTAs, some closed models, open source models, and so on and so forth. But probably it's hard to tell that which one is the source of truth or which one that you can trust for the long term. So here we are working with AI Alliance as well as IBM to propose a evaluation framework where people can leverage to help them with the model evaluation, especially for the domains. But first of all, I want to talk about some background of this space as alongside the AI waves. So generative AI has to be useful before we talk about safety and security. So of course, today we are gonna more talk about the safety stuff, security more about adversarial attacks, prompt injection, jailbreak, tap pair, those kind of stuff. We're gonna skip. But today we're gonna focus on the safety related stuff. Alongside algorithms, computing power, and data, there are so many use cases has been landed pretty well infrastructure-wise. That's where people can have the empowered landing and adoptions. Vertical-wise, so people are using this in various domains such as healthcare, banking, insurance, education, so on and so forth, to reduce the cost and increase the efficiency of productivity. Also applications, right? There are tools and information sharing, entertainment-related stuff. Of course, the computing power, where people leverage a bunch of the company's resources for the inference, fine-tuning, and training. But today we're going to focus on the verticals, which are the domains. Why is that? It's because they have the real-world problems, and those are very specific, where we can directly work on those to solve a specific problem. But that's more about the domain. How it looks like in the AI safety and security space. So back to 2023, I think everyone is familiar with the very big wave where generative AI was growing really fast. But back to then, people probably talked about the buzzword of the safety, security, and those stuff, but people barely spend a lot of time in depth working on the AI safety and security stuff. So back to the, in this year, so we have been working on a bunch of the safety-related issues, security-related issues in terms of the risk identification and mitigation. And that's mostly about the very generic topics. For example, the model itself, the applications, the cloud hosting providers, the SaaS things where people can integrate and easily leverage those for their use cases in a very generic point of view. But people barely spent a lot of efforts and had a lot of successful landing scenarios in the domains. for example, BFI, banking, financial insurance, education, a bunch of others. And that's where we are going to focus on this because they have so many private domain data. They have so many use cases. And that's where we want to help them to leverage or adopt the generative AI more and more, and where they're going to use those in a safe way. Because of this, we work with AI Alliance and IBM to propose a project called Comprehensive Evaluation of Large Language Models in the high-stake domains. And basically, we have one objective or goal. We want to ensure that LLM meets the standards for accuracy, compliance, and ethical responsibilities. There are two challenges. So I won't read this out, but there are two main challenges that we want to address within this effort. Number one, the lack of the benchmarks. There are a bunch of the benchmarks outside, and probably you saw some of those, and probably not all of those are updating frequently. So how we can leverage this information to help us or guide us through in terms of which model to use, what are the vulnerabilities inside, which fit in my use cases best. So that's where this benchmarks in a way that people can trust as a source of truth is very important. Also, knowledge is important, but basically I think people need some tools to help them be more efficient. So how we can create those necessary tools alongside this kind of the effort where people can directly use those tools to help them get the understanding and help them address the issues and help them to get into the adoptions what they're looking for is also very important. So these are the two challenges we're looking to address. And of course, we have a bunch of things we want to achieve, and based on which we're gonna work on something, deliver something, and provide something in the end. But there are two very important things I want to mention here. Number one is when we're working on the domain-specific ones, domain expert is very important. It won't be something that's super generalized and everyone can work on those easily. Domain input, domain experts input is kind of critical for this effort to be successful. So that's where we backed by a bunch of the domain experts and the real-world applications. That's gonna help us to guarantee the results of this effort. Number two, this is kind of the industry first recommendations. So probably you check something on Hugging Face, probably you check something from the Stanford, probably check something from other website. But we want to have the aligned understanding of this effort. In the end, if that's something that people agree upon and people can really gain value from it, that's kind of the successful story. And also for the highlights, we are going to focus on the existing pre-trained models. Eventually, we want to cover everything, but we have to start with something first. So we focus on the existing pre-trained models at the very beginning, and based on which we will provide a bunch of the attacking method, that's where I list here, as well as the content categories where we're going to support and cover. For example, misinformation, bias, sexual content, so on and so forth in the initial version. The plan is kind of long. So basically we have a design, we build an MVP, we develop it and generate a report and get feedbacks based on which we keep iterating on it. And eventually we provide something which is mature as a guidance. And we present this to the public people and people can start to use it. And at the very end, we will provide the standard as well as the toolkits where people can directly use it. 2 case studies I want to share with people. There are so many domains, as I mentioned. The first one I want to mention is the healthcare. So healthcare had some successful landing scenarios in the past few months or past year in terms of notes taking, image recognition, diagnosis, so on and so forth. So basically for this case, where we're going to help with a clinic or hospital to help them to provide the sensitive information of the patient, of the diagnosis staff to make sure those are safe and secure. At the same time, the doctors can leverage these capabilities to be more productive and help the patients better. Also, education is another good example. So basically, it supports both the teachers and the students. So teachers can leverage this to prepare the teaching materials easily. And the students, especially for the students, they don't have a bunch of the good resources of the teachers. They can leverage this to be the teacher assistant, to learn stuff, and of course, do some offline courses by themselves. And that's where we need to protect the students' information as well. And also, this will be the tool where they can help the students to learn better, even there's no teacher. And we have been working on this for almost 10 months-ish since the very beginning. And we have already built a platform. It's an early stage version where it supports almost all the generic use cases. And the attacking method and contents are actively being added, but currently we have 20+ attacking method and 30+ contents or categories. Domain-specific ones we haven't added enough yet, but we are adding those gradually. And of course, feedback is very welcome. And I'm going to play a small video, which is going to show people how this platform looks like and what information it provides and what it can help with people with. Actually, it has sound, but probably I'll mute it. Basically, this is a platform where people can start evaluation, and you can pick the model which you want to evaluate against. And of course, you need to pick like how many categories you want to run against. Statistically, if you only run one, probably the result is not super guaranteed. But if you run like more than 1,000, the result will be very much converged. And this is one of those examples based on what is a data type, blah, blah, blah. And that's the input and output. And based on which we get, I cannot scroll it down, but it's here that we show the safety score, the probability, the confidence level, and also the rationale that why we think this is a skill or not. And after we run a bunch of the evaluations for every model, we will have this type of the reader chart where people can see the performance of a model from various angles. So for this one, if you're talking about overall safety stuff, so we have the sexual content as whatever. So in the end, I will put the QR code. If people are interested, you can just scan it and play around with it. It's free. And this is the effort that we're working with AI Alliance and IBM. So these are the roles and the responsibilities. I won't read it out. But if people are interested in this effort, welcome to join us or at least speak with us. So we definitely need more people to work with us, especially the domain experts. A little bit about who we are, because we talk about what we did and what we are working on. So a little bit background of who we are. So we are Hyrdox AI. We're working on AI safety and security. So I talk a lot about the safety stuff, but we are also very strong in terms of the security stuff, in terms of the red teaming, attacks, mess up with the models, or distill data from the models, or RAG or vector database, and a bunch of others. And also we provide solutions to help people to prevent those from happening. So these are some stuff. And this is a team. We have a very strong team with a bunch of the traditional hackers and strong engineers. So in the end, if you have any questions, feel free to ask me. Also, we have 2 QR codes. If you're interested in the evaluation platform where you can evaluate a model, feel free to play around with it. Also, we have the AI safety community where you can learn stuff, as well as we have a capture flag platform where you can attack the model that we deploy to play around. So thank you. Oh, I think that's you. Oh, you need a mic?
Thank you. Thank you very much for this talk. Question, can you talk a little bit about how the technology actually works? If you have a very domain-specific problem, like semiconductors, eventually you need somebody like Dr. Christopher to verify if the question is correctly answered by the model or not. How do you route domain-specific questions from experts? At which point? Do you use it only in the preparation or in the evaluation? Can you talk about that?
Yes, of course. I think that's a good question. Not sure if everyone heard about that, but he was asking about domain expert, like how they can help, where we can pull the support from them, and how that is going to be involved. So basically, there are 2 steps. Number one, there are a bunch of things are pretty much generic. So it doesn't have to be like domain expert related. For example, the framework, system, routing stuff, as well as some very, very basic attacking method and the problems. And once that is set up in a kind of relatively mature way, after that, we will have the platform where you can check it out, where people can add a domain, a specific categories by themselves. You call it bundle. So for example, you are the expert of the e-commerce, and you have a bunch of the categories you are interested in. So you can create a bundle by yourself called e-commerce, and where you can put a bunch of the categories you are interested in or you care about under that bundle. And where we are gonna run this through the our evaluation system based on our current knowledge. But of course, after we gather evaluation result, you will get all of those by yourself, and where you can check those out. Give us some up, some down. You think this is wrong or right? And if it's just like a few data which is inaccurate, we can easily do a fine tune. We have a judge model by ourselves, built by our team. But if we found out there are a bunch of things are missing, definitely we need to work closely with that domain expert, where we need to bring a bunch of things new. So 2 steps. And we are at early stage of the domain support because we were focusing on the generic use cases. But I think what you mentioned will be something that we need to work on for sure.
Where? We'll take a question or two. Yeah. Okay. I don't know who was first, but we'll go with you.
I saw that on your slide you had like 2 industries, healthcare and education, and I'm curious if you could speak about like a particular use case. Maybe if you have like a pilot partner, or what would be like the specific use case of like using your product by a company.
In terms of the partner name, I'm not sure if it's okay to share, but I can talk about the use cases. So I think I mentioned a little bit about the healthcare. I think those are specifically for the doctors. So basically, doctors, they have limited amount of time, but they need to work on a lot of things and face unlimited amount of the patients. So I think people know that note taking is one of the things take majority of their time, 40% or 60%. I don't remember exact number, as well as the so probably you take some, I don't know, CT or something to get images, and people need to read those images. And of course, people need to do some diagnoses. Some of those are super complicated. Some of those are easy, but where is the best use of the doctor's time? That's where the model can help with. But that's not what we're working on. So some AI companies will work on those, but we are going to guarantee that those process, the results and responses are secure and safe. So for example, they have their own RAG or vector database, or they have their own logic. We are going to help them make sure that through the API, the input and output, upstream, downstream are secured, as well as they have some private domain information. We need to make sure those information won't be distilled out to leak the sensitive information from the users, patients, or probably the hospitals. So that's where we're going to support with. And I think at least the diagnosis is a very strong need where we can work with the doctors to make sure that at least they can leverage this to increase their productivities in a secure and a safe manner.
Okay, was there one more question? Okay, question. One more question.
Thanks. What best-in-class percentage accuracy have you observed in these high-stake domains?
So basically, when we are talking about the this kind of the core metrics, we normally don't use the accuracy, but of course we have such a number. It should be very high, but based on our ground truths and the golden rules, it has to be high until someone, that's why we open it where people can give the sum up and sum down or inputs to make sure that we are not the only source of truth. We take the inputs, but based on our stuff, based on our knowledge, of course, we make it to a super high accuracy. And based on that, beside that, we also care more about attack success rate. That's where we have something that we know this is malicious. For example, safety issues, and where we have those as the comparison, something that we can compare with in our database, where whatever the results that we have, we will compare with that. But beyond that, we have something called the judge model. So that's what we build. It's a LLM, but it's pretty small. So where that thing is trained by ourselves, they have the knowledge of the attacking method and those kind of malicious input or malicious prompts. So it learned from it. So if we believe that judge model is very smart and very well trained, so this model should be able to recognize any attacking method and any malicious output or prompt. And that thing will give us the output, the labeling, the probabilities, and the rationales. So based on that, currently, I won't say the accuracy is 100%, but based on our current knowledge and the data, it's pretty high.
Okay, we have one last question just because he's sitting right next to me and I can't get away from him. So here you go.
So one thing I didn't see is whether you publish how you compute your scores and whether or not you're preventing any kind of gaming.
Prevent what?
Preventing any kind of gaming of those scores.
Oh, yes. Yeah. Oh, that's a very good question. Yeah, I should mention that, but I forgot. A bunch of the testing set, I'm not saying what is good or what is bad. I'm just talking about the current fact that a bunch of the testing set is static. So basically, it's kind of predefined. Basically, if you train the stuff based on that, it's pretty easy. You get a super high score, even 100%. So basically, our data set is dynamic. So basically, we have the seed and we have the algorithms where we can generate unlimited amount of those. Basically, it's kind of like you cannot prepare your examination based on the questions that you know already. So basically, we give you some questions that you need to answer, but you learn from a different set. So that can partially prevent that from happening.
Great. Thank you very much.
All right.
Thank you everyone for your good questions. Okay. By the way, just as a, oh yes, please. Again, I was just wondering if it was still true. I had a friend of mine say, oh, I'm involved in safety issues around generative AI. And he happened to be looking for, what best practices were. And he told me, I didn't know this, but he told me that if you go search for AI trust and safety guide, our work shows up number 1. So we're doing something right. So if you open up your browser and go to, the private, so it's not tracking what you've seen previously. And yeah, search for AI trust and safety guide. You can see our work. Okay, so next up, we've got Amit Sangani. He's the, let's see if I get it right, Senior Director of AI Partner Engineering. And he's from Meta. So please welcome Amit. And while Amit's getting started, I'm just kind of curious, just how many of you have actually used Llama? Oh, I guess at least half. Excellent. You got some friends. You got some friends in the house. Is that working?
Yeah. Thank you for asking that question. So about 50% of the people have used Llama. So what I'm going to do today is talk about Llama, obviously, but I also want to talk about the unprecedented growth of Llama. And I saw 50% of the people raise their hands. I would love to see 100% of the people. And there's a reason why. Since we launched Llama in 2023, we have seen over 350 million downloads. And just last month, we saw 20 million downloads. So Llama is clearly seeing unprecedented growth. And that is why I think you all should care. We are seeing tremendous amount of applications being built right now on Llama. And I want to talk about how these models are built. This is an intro. This is not an advance. So most people should be able to get it. But I also want to go into details around the architecture and how we built Llama. The foundation of Llama is open source. And I'm going to talk about why we open source all of this, why it's beneficial for developers, Meta, and the world. But before we do that, we have seen this exponential AI growth over the last several years, right? But AI has been going on for the last 50 years. And as you see on the y-axis, the training computation, which is measured by flop, which is floating point operations per second. In 1950, it was about 1,000 flops. And today, we have 10 billion petaflops. That is like over 100 trillion flops per second. So these are the amount of operations you can compute within a second. And that is the power of a lot of the GPUs coming from NVIDIA, AMD, Intel, and many other players. And that has enabled us to build amazing software like large language models like Llama because we have that amount of training powers.
We also see the pace of this innovation has surpassed Moore's law, which is crazy. And the potential of AI is a mega trend. What has happened with internet and computers, desktop computers, we think AI is the same revolution which is going to bring over next decade. And the progress is palpable. Just last year, if you would type in a giraffe riding a bicycle, you would see this photo, which is on the left. Actually, yeah, on the left, where it's a cartoonish image, right? And today, in 1 year, that photo is super realistic with high fidelity. And even now, very near future, you'll be seeing this giraffe actually riding a bicycle. So this photo can convert into a movie and sing your best song, your favorite song, with lip syncing. So that's how fast the market is moving. And the foundation of all of this is large language models. And that's why we are super excited about Llama 3.1. I want to talk about 3 things today. One is the open approach, why open source is good for the world, for Meta, and developers. I'll talk about Llama systems because models is one thing, but we are building things beyond the models. And then I'll talk about trust and safety tools. Today, we heard a bunch of things about trust and safety, and I want to double down on that as well. But before we do that, let's talk about the evolution of Llama. In February 2023, we launched Llama 1, which was just for research purposes. This was not for commercial purposes, but we got overwhelming demand from organizations, Fortune 1000 companies. Like, we want to use this model in our production systems. So we made a very bold decision to launch Llama 2 for commercial purposes. And we open sourced this. To actually build this model, it's cost tens of millions of dollars. And we just gave it away. And there's a reason why we did it, and I'll talk about that in a bit. After launching Llama 2, we saw that there were popular use cases like code generation, code analysis. So we launched Code Llama with larger context window, where people can take entire files of code and actually put it as an input prompt. And we also launched Purple Llama, which was our first trust and safety Llama Guard models and CyberSec evals. We launched Llama 3 this year in April 2024, the 8 billion parameter model and 70 billion parameter models. And they were far more advanced models than what we launched in Llama 2. In fact, the 8 billion parameter model for Llama 3 was actually better than the 70 billion parameter model for Llama 2. And July 2024, we launched another version of our models, which are, again, better performant than 3.0. But we also launched the 405B model, which is the largest model, open source model we have till date. Now, the first fundamental question, which is in everyone's mind, why is Meta open sourcing all this, right? We have spent tens of millions of dollars around it. We fundamentally believe that open source AI is good for everyone, starting with developers who can take these models and fine tune it, train it, distill it, and use it wherever they want. Companies who want to protect their data and does not want to give it out through an open AI or open API, they can actually still use Llama and launch it or deploy it on-prem and still use it without worrying about where their data is going. And we need a model which is efficient and operational. And that is only possible if you open source and you have the community building on top of the open source. We have seen Grok actually run these Llama models at 50% more efficiently within just 24 hours after we launched, and at much lower cost than GPT-4. Now, this is beneficial for developers, clearly. What is in it for Meta? As you all know, Meta is in the business of consumer apps. We want to build the best experiences for the consumers. And to do that, we want to make sure that we are not dependent on anybody else's core infrastructure technology, such as LLM. So we want to have access to the best technology. We want to make sure that we are not locked into the competitors' platforms, which is what happened in mobile space. Only 2 major companies are running those mobile operating systems. And we are succumbed to what they tell us to do as developers, right? And so that constrains the creativity we can bring to our consumer apps. And there's a side benefit for us. When all this innovation and contribution happens, we get to use it for free. So imagine we have thousands of engineers working on this, and we don't have to pay them, right? So that's the advantage for Meta and the world. Open source AI, we fundamentally think is more transparent, is more safer, and is widely scrutinized, which is good, because when you can scrutinize it, you will find issues, and there will be people, including Meta, who will fix it. Open source will also ensure that more people around the world have access to the benefits and opportunities of AI. Any developer sitting in India or Africa should be able to download these models and build on top of it. It should not be constrained to some large tech companies in Silicon Valley. And that is why we are super honored and excited to participate with IBM on AI Alliance and 100+ members. A lot of the trust and safety tools, which I will talk about, was built in coordination with a few companies within the AI Alliance. So let's talk about the models which we launched. The Llama 3.1 models, we launched the core models, which are pre-trained models. These are the base foundational models, which uses a standard decoder-only transformer architecture. Then we launched also the fine-tuned models. So these are optimized for dialogue use cases to build customer service chatbots and intelligent agents, which we run multiple rounds of supervised fine-tuning, RLHF, rejection sampling, direct preference optimization, and so forth. And on the right, what you see are the models, inference guardrails, which I'll talk about in more detail in the next slides. When we launched Llama 3.1, we basically built larger context window. This is the number one ask feature that, hey, we need larger context window. We need more data within our prompts to be sent to the model. So we increased the context length to 128K. We provided multilingual support, so it has 8 languages support, but this is going to increase exponentially in our next version of the model. And it uses state-of-the-art tooling. What that means is it can do long-form text summarization, multilingual conversations, and agents. So you can do tool calling. So if you want to do real-time search for data, it is able to do that. And we have also made changes to our license, which I'll talk about here, where we can do synthetic data generation with 405B, and it's super critical, and I'll talk about it in a bit. We launched 405B. This is our largest model till date, and we have different flavors. As you can see, FP8 is floating point 8, and MP16 and MP8 is mixed precision 8-bit and mixed precision 16-bit. The reason why we did that is for inferencing these model, you need a multi-node GPU infrastructure, which is pretty complicated. So if somebody wants to serve this model through a single node, they can still do it with MP8 or FP8. This is a state-of-the-art model used by a lot of large enterprises already. It supercharges innovation across the board with new applications which are possible, which are not possible with the smaller models. You can do synthetic data generation. So what that means is, let's say you're a healthcare company or a financial company, and you want to create a niche model. You already have the data, but you can also generate data from 405B, which are finance related, and then use that data to fine tune that smaller model, which is very powerful. None of the other LLMs, as far as I know, allows you to do that. So this was, again, the number one feature where you want to build these specialized models and then orchestrate it and work in conjunction. You can do it through synthetic data generation. And then you can fine tune this, you can distill it. Distillation is a process where you create a student model and you can deploy it on any infrastructure. You can deploy it on the cloud, on-prem, or on mobile. So we are super excited about this. And this, when we designed the architecture for Llama models, Llama 3 models, like our primary concern was simplicity in deployment for majority of our companies. And so these models were trained on 15 trillion tokens. And to train that much data, we had to use 16,000 H100 GPUs. This is by far the largest model we have trained. And the scale at which this is trained is just humongous. And it uses the standard auto-regressive decoding architecture, transformer architecture, which has self-attention and feed-forward network and so forth. And the results were outstanding. As you can see here, we basically did a benchmark testing across 150 different data sets. And we found that Llama 3.1 stack ranked very well against GPT-4 and Claude 3.5 Sonnet, which are world-class models available right now. And as you all know, we talked about this, just industry benchmarks is not enough. You have to do human evaluations as well. And so we did extensive human evaluations with 2,000 prompts, 12 different use cases to make sure that these models, when deployed in real-world scenarios, are really working as it should be. And again, as you can see, the human evaluation results are pretty good compared to our other models out there. The Llama ecosystem is flourishing. We have, on day one, when we launched these models, we had all these partners from cloud service providers like Databricks, AWS, Azure, GCP. All of them had the models available for their clients. We also had partners like Dell who are building an on-prem solution with this model as the foundation layer. And we have IBM, whom we partnered across PyTorch and Llama models. And all these models are available within their infrastructure as well. Then we have global system integrators whom we leverage to target Fortune 1000 companies. So a lot of these Fortune 1000 companies who need more detailed help in architecting, designing the Gen AI applications, they are basically using Llama as well. And it's very important for these models are at the foundational layer, which is just sitting above the bare metal. So you want to make sure that these models work efficiently. So we partner with all the silicon partners like NVIDIA, AMD, and Intel. And what you see here, so models is one thing, but we also need other services like fine-tuning, RAG, data generation and distillation and so forth. So on day one, all these services were available across all these 10 partners, actually over 25 partners. We could not fit in all 25 partners here. But each checkbox required a lot of engineering work across on the partner side and Meta side to make it work. Now, all of this is available out of box, right? So if you are a Gen AI developer, you can get these services depending on which platform you are. And many of the large organizations are multi-platform, so they use multiple vendors here. So you saw what I had talked about, basically the models, but models is just one thing. What we are thinking is beyond the models, which is Llama system. Our vision is to go beyond the foundation models to give developers access to a broader ecosystem, and that gives them the flexibility to design and create custom offerings. So I'm going to talk a little bit about the Llama system. So when we launched 3.1, we actually launched 2 GitHub repos as well. One was called Llama Stack RFC, and RFC stands for Request for Comments, and we have got almost dozens of comments on there. But our foundational understanding, reason to do this was we want to build and bring comprehensive set of APIs for developers who are building on top of our models. And these APIs will really define the orchestration layer of how these models will work in real production environment. As you can see here, there's all these steps, like from data sets to fine-tuning to aligning to evaluation to inferencing and monitoring. All of these steps are required to build a successful Gen AI application. And Llama model becomes the foundation piece. And so we plan to come up with API interfaces, which is on the left, which you see here. And then we basically expect companies to build different adapters on top of these APIs. So we are not going to build the adapters. We are just going to define the interface. and open source all of this so that companies can build adapters and verticalized distribution. So think about Linux, what they did with Linux operating system compared to Unix. And the second GitHub repo is where we build the sample apps, the demo apps on how it will build. So if you are building an agentic application, you will have a user send in a query. There'll be an executor piece here in the blue, which will be basically all these services. And there'll be an orchestration layer. And there'll be a large language model like Llama. And then you can be able, in general, you should be able to call an external tool like Google search. So if you're searching for something which is recent and Llama does not have that, then you should be able to call that in real time, or a calculator if large language models cannot do complicated math calculations, right? So this is the whole vision around this. What you see in the video is one of the samples where it's basically asking to generate the matplotlib, I believe, and asking like a bunch of questions. And then it's basically generating the code for that. So let's talk about trust and safety. This is also very dear to our heart. When we launched our models, we want to make sure these models are safe to use. So inherently, our models are extremely safe, but we also provide tools which can make it even safer depending on your needs. So for example, like healthcare might need more safer taxonomy than some other companies in different industries. So when we actually build the models, we made sure that the data is tested across all representativeness, right? So we want to make sure there's no bias in the data. We evaluated for harmful content, and we made sure this, as part of this process, that there's constant benchmarking done and evaluation done, and the feedback is set back to the data preparation team so that data can be cleansed and refed it. Then the process goes into the safety fine-tuning. We basically do the supervised fine-tuning. And then we partner with the red teaming experts. And these are cybersecurity experts. These are external companies, not inside Meta, who basically stress test the models and gives insights of how these models are performing. And then we basically iterate through the process again to make sure these models are extremely safe before we launch it. And we basically believe in open approach for everything. So everything which I've shown is all open source. There's nothing private to Meta. And especially for safety, we have partnered with ML Commons for their taxonomy and taken all the harmful categories, taxonomy for harmful categories, and deployed it in Llama Guard. We launched these guardrails and models. So Llama Guard is both input and output safety. So you have your LLM, which is the middle box, and then the blue, before the input prompt goes, it is going to the safety guard, going into the model, and then output, there is also a safety guard. So you can structure your system in such a way that you can have these additional layers of safety. And you can customize this completely. So these system safeguards is customizable. You can add taxonomy, you can remove taxonomy, and so forth. The prompt guard is to mitigate risk against prompt attacks caused by prompt injection or jailbreaking. The code shield adds support for inference time filtering of insecure code produced by LLMs. And CyberSec eval is a comprehensive set of evals for cybersecurity and safety evaluations. And so AI has been obviously a long part of Meta's DNA. And we believe AI can be beneficial for all when it's responsible, integrated, and open. And we have partnered with, obviously, AI Alliance members, but we have also many, many years of experience. The fundamental AI research team, which Jan LeCun started, is now 10 years old, and we have world-class AI researchers in that team. We have published 20+ system cards, which explains how AI powers experiences across Meta's technologies. We have 100+ members in AI Alliance, and we have open source 1,000+ projects. And some of the popular projects are PyTorch, Llama, React, and so forth. So let's talk about some of the success stories. Obviously, we have hundreds of companies using Llama, but I chose some of them which were unique niche cases. So we have actually partnered with IBM on Watson X to bring Llama to GenAI, Llama and GenAI applications to Grammys. We have partnered with Niantic to build an AR game which uses Llama to enable virtual pets. Audi is using Llama to build customer service agent. These are agents to enhance the shopping experience for the customers. We have worked with Shopify, who have used Llama to automate tasks for their business owners. And they have tasks like report generation or bringing in more insights, generating product descriptions, responding to customer inquiries, and so forth. We have worked with Kevlar to optimize cybersecurity. Now, when I say we have worked with, means they have worked with Llama models, but we initially helped them when they had some issues around it. And so that also helped us improve the models. And Lyra is a matchmaking organization in Africa, which has used Llama to help the human recruiters as well. And these are not the only companies. We have worked with AT&T in USA to Orange in Europe. These are large telecom giants who are using Llama for their core business and really seeing massive improvements. Financial giants like Goldman Sachs, companies like DoorDash, Zoom, Nomura, everyone is using Llama models. And here's a pretty detailed use case. So if you want to, you really look at the end-to-end process, right? Meditron has created this. Meditron is basically a partnership with Yale and EPFL, which is a Swiss Federal Institute of Technology. They have basically shown how to democratize access of medical knowledge. And they took the Llama 2 models. I think they have just upgraded to Llama 3. They fine-tuned that model with medical data sets like PubMed, papers, abstracts, and general medical corpus. And they've created a model which is outperforming LLMs on medical reasoning tasks. And this is all open source in that URL. So if you just go to Google and search for Meditron and Llama, and you'll see that GitHub link, which you can go and see the entire end-to-end use case. So if you're interested in building a small GenAI application or a large application for your company, this is the use case to follow. Okay, I've talked enough about the Llama models. So what's next, right? What are we going to focus on? As you know, we are building, all our apps are using AI. And so we'll continue to bring in new features which are powered by AI. Ray-Ban glasses are also now being powered by AI. And many of you may have already used it. We launch a segment anything model as well, where you can get segments out of an image. And we are going to bring AI to MetaQuest as well. How many people have used Meta AI? Okay, a lot of people, which is good. Thank you. Last year when I asked this question, there were like less than 5% of the people. So I'm glad that people are using Meta AI. But Meta AI is very similar to ChatGPT, but it's free and you can use to generate images on the fly. As you type in, it will generate images. It's powered by 3.1, Llama 3.1. And you might have used Meta AI on WhatsApp as well. It's available on web and WhatsApp. And if you're using it on WhatsApp, it's now powered by 405B. So you'll see the difference in the quality of the answers you get. Llama models are powering all our consumer apps, so Facebook, Instagram, Messenger, and obviously WhatsApp. And there's a bunch of things that you can imagine yourself. You can do image edit as well with these models. But the most interesting thing is the Ray-Ban Meta. So Meta AI will come on Ray-Ban Meta, where you'll be able to take any picture, but not only picture, what you see, you can just ask Meta to tell, like, what are you seeing right now? And it will be able to capture that and send it in real time to the Meta on our server, and then be able to give you the output. We are also very excited about the Llama Stack initiative. As I talked about, the agentic system is going to be the future, where you will have multiple niche agents doing work in synchronism with each other, and there'll be orchestration around that. We have already seen multiple workflows in large companies where the output of one model is fed as an input to the other model. And to build that, you need the full stack. So you'll have the machine, but the model, and then a bunch of libraries. So the libraries you see here, we have put in PyTorch. And then the whole tool chain, right? The services which we talked about, the fine-tuning, the inferencing, and so forth, which will allow developers to build these agentic applications. So that was my last slide. If you're interested, if you haven't played around with it, go to llama.meta.com, get started, and you should be able to download these models. There's how-to guides on how to use it. But I want to end with one very important note, that we are extremely committed to open source. And we strongly feel that innovation in open source is critical for the advancement of AI across the globe. And we also strongly believe that open source will allow us to build safer products, better products, highly innovative products, and healthier overall market. This is good for developers. This is good for Meta. And it's good for the society and the world. Thank you. Good.
Great presentation. Thank you. You mentioned the effort that Yale used fine-tuning, and then the first presentation that we saw for semiconductors, also, I think when they said powered by Llama, they probably meant fine-tuning. Any guidance on when you would recommend fine-tuning versus RAG? Is there a threshold for when you approach a challenge that you're like, no, I should really research fine-tuning?
Yeah. So the question is, when would you use fine-tuning versus RAG? It's a very common question. If you have large amounts of data, RAG has limitation, right? There's limitation in the context window, limitation in how much you can fed in the vector database. Now, you can fed a lot of amount of data in the vector database, but every query now you have to search through the embeddings and get that section before you send it to the model. So if you have large amounts of domain-specific data, I would always say do fine-tuning first, and then you have recent data, you do RAG on top of it, right? So you don't have to select one or the other, you can do both. And most use cases we have seen, they're doing both. And there's something called RAFT as well, which is retrieval augmented fine-tuning. This is real-time data, which is coming in, and you're continuously fine-tuning the model, which is also becoming prevalent because of reduction in costs of fine-tuning. So if you can fine-tune your model every 24 hours, and the cost is not that high, the new data comes in, you pick that data, fine-tune your model so you can generate reports. It could be 24 hours delayed or 12 hours delayed, but it's still better than having a report which is 6 months old, right?
There was, okay, we'll go here.
You're at the most elite level in dealing with unstructured data. What stops you from releasing the runbooks and the code, which would be a natural part of that, so we all could learn, you know, at an elite level how this works?
Sorry, I didn't get the question. Are you saying we should release the code?
Yeah, how you put it together and the run books of how it's put together, because it's not really secret sauce. Like, who else can run it? Like, the people who could run it already know how to do it, but sharing that as well, wouldn't that be hugely educational to people like us?
Yeah, so are you saying like how we run these models? Is that what we?
Yeah, like how you did the inference to clean up, say, Wikipedia and so forth to make the models themselves.
Yeah, so we do share that. If you look at our research papers for the models, it's a pretty long research paper. So we exactly tell how do we did red teaming, how did we make the model safe. What we don't disclose is just the data sources coming into this model. And there's the reason why we don't disclose is because of the legalities, because we basically license some data with our customers, from our customers. But other than that, all the data which is publicly available, which Google goes and crawls, these models have that as well. We also showcase, there's something called Llama Recipes, which allows you to, which my team has built, which goes into a lot of details around how to fine-tune a model, how to do evaluation of these models, how to do inferencing of these models across single node or multi-node infrastructure. So we are trying to train people to use these models, and we are basically doing all that education as well. Yeah, we are not shying away about sharing any of this code at all.
Any more questions? Oh, okay. Hold on. We'll start here.
So you just mentioned that you're licensing data, and I was just wondering what kind of dimension, like of spend, or so how much in cost is that when training a new model?
Oh, so from like Llama 3.1,
yes.
What is the cost? I don't know the exact cost, but every training run, I think internally they say it's about 25 million, and we do like 4 or 5 training runs for the model. So you're talking about $100 million to train these models. And the licensing of the data, I don't know really. Yeah.
Okay.
Yeah, but obviously that is one-time cost, right? The key cost is the infrastructure to train these models.
So I was just wondering, because normally it's all about the GPUs, about, making engineers, but nobody talks about like actually paying for the data, because most of it is public and not very much licensed. That was, the source of my question.
Yeah. But also these models are, once you have enough data in there, these models are becoming more and more intelligent because of the architectures that they can generate data, which is as useful as real-time data. So you must have heard about zero-shot learning and few-shot learning, right? Where these models can based on really small number of examples, can learn very quickly and generate data output, which is quite intelligent. So yeah, we still need specialized data sets. So if we are targeting certain industries, we need that data set for the models to learn the basic, but then these models are able to infer from that very quickly.
Okay, we have time for 2 more questions. I know was there one over here? Over there, okay.
So at that extreme cost, is there some way to defray that cost by spreading it across like more than one participant in the same sector, where normally competitors would never talk to one another, but for a generic training, they'll get together and say, yes, we want this, and we'll pool our resources, and then we'll specialize it to our own needs, but we'll at least have a pre-trained model that doesn't cost millions of dollars. Is that something that's come across your plate yet?
Yeah, it's a good question. The benefits we gain out of this is way more than this cost. So even though we open source all of this, I did tell you like why Meta gets benefited significantly, because not being dependent on somebody else's core infrastructure technology is a massive insurance to our business. And so for us, even though we open source all of this and we are highly committed, this is way beneficial to Meta over the long run. So, and many of you know that, when the mobile operating systems came in picture, Google came out with Android, iOS was there. Facebook, back then it was called Facebook, was trying to build an operating system on mobile. And they failed. They shut it down when they went IPO. And the reason why they were still trying to do it is because they didn't want to become dependent on somebody else's operating systems, right? And so we do think that AI is going to be as big as mobile in the future, and we don't want to be dependent on somebody else's technology. So to answer your question indirectly, we are not concerned about the cost, because the benefits far outweighs the cost, both for us, and I think by open sourcing, this just benefits the world as well. And plus, we are not in the cloud hosting business, which also helps. We don't care about keeping our models closed and then charging customers to use those closed source models, right? It's not, we are not in that business. So we are kind of commoditizing the LLM market as well.
Okay. Yeah, we've got a question up here. Max has good questions, but oh, good.
Yeah, these are tough questions, but those are good questions.
Hey there. So I imagine that dog fooding the product is really important to being such powerful evangelists for Llama. So I'm curious if you have any exciting internal use cases for Llama that you're able to share with us.
Yeah, so we have an internal product called MetaGen, which is similar to Meta AI, but it basically has access to all the code. So you can literally, if I'm working on an application where I want to see like, hey, is this code written by somebody else? I just ask a question in a natural language and it will give me that code and sources of the files as well. Another interesting use case, so Meta has performance cycles every 6 months. And when the performance cycle comes in, you have to write your own self-review. And when you have to write your own self-review, you have to start now looking back 6 months into all your emails and posts and data to gather all the golden nuggets and create that self-review. MetaGen internally has a feature where you can say, hey, I'm writing my self-review. Tell me all the great things I've done in the last 6 months. It will create a full report and give it to you. So that's a big time saver for the entire company, right?
All right. That's a great, I think I like ending on those positive notes. That's a good use case. So we're going to wrap it up with this and go on to our next lightning talk. But I want to thank you very much for excellent
thank you
sharing knowledge today. Thank you. Okay, our last talk is a lightning talk. So this will be short. And this is Jed Pitera. He's with IBM. He leads one of our AI Alliance working groups, specifically in the materials area. So for those of you who are wondering, where is AI in the rest of the world? Well, it's a big world out there, and they have a working group focused on it. So you look like you're set up. Okay, take it away.
Yeah, so lightning talk, going to be super quick. I understand that I'm between you and networking and all of that sort of thing. But we started this program introducing the AI Alliance, and I just wanted to give you a brief example of some of the how, right? So what does a working group in the AI Alliance look like? What are we doing? How are we thinking about it? And I'm going to frame that in the context of materials. Part of the reason for doing that, and part of the reason this is interesting, is that materials data is diverse, materials data is unusual, and materials data is very irregular. So we don't have the same level of normalized data that we do in other domains. What that means is that we're doing things like exploring unusual model architectures. Rather than looking at single massive models, we're asking questions about when it makes sense to create models for individual modalities, and then what technologies we can use to either fuse or align those models, and how that can be effectively made use of for either latent representations or cross-modal inference. We actually just put out the first model that's associated with the AI Alliance Working Group from IBM. You can see the fellow who built the model up there on top. He's from our lab in Brazil. And if you're interested in the model, there's a QR code right there, or just approach me after the talk. But it is a relatively large, but not enormous transformer model. It can't be enormous because, as I said, this data is kind of irregular, it's kind of varied. And so we have to be parsimonious about the scale of the models that we use. But it still gets state-of-the-art performance on a series of benchmarks on molecular properties. So that's just an example of tools that we're making available as part of the working group. We actually had our first monthly meeting this morning at
at the lovely hour of 7 in the morning, just a warning for you. It's a team that works across the globe. And so we do have to accommodate everybody's time zone. But in terms of how we're thinking about how we participate and how we collaborate in this kind of organization and in this kind of structure, there's some aspects of materials that are very proprietary, right? If I invent a better mousetrap, I want to have the rights to profit off that mousetrap. But the underlying technologies that help me make that mousetrap are things that we probably want to either develop together or that we need help in developing together. And so we have work streams in terms of the model, thinking about modalities, multi-models, single large models, work streams in terms of data. One of the challenges in the material space is that we don't have a lot of good benchmarks, particularly for multimodal or cross-modal tasks. Another work stream around the tooling and the infrastructure. So how do you make effective use of one of these complex models or complex model architectures? Some working examples in workstream 4 of fine-tuning for particular domains or particular applications. And then in workstream 5, trying to get feedback from the industries and from the people that are using these models and trying to do so in industrial applications to say, look, this is where this model is working, this is where this model is not working, or here's a gap in a modality, right? I really need a functionality that is missing in that model. So last thing I'm gonna do, and I should get out of the way of the QR code, is just say that if this at all sounds interesting, it's an open, very collaborative group. And if you're interested, either hit that URL or that QR code, or reach out to me and we can bring you on board and would love to have you participate. So that's it for now, and I'll answer any questions.
All right, we are getting towards the end here, so we'll take, if there's any questions, we can take a question. Any questions? Okay, going once, going twice. Did you have a question? Yeah. Okay, great. Here you go.
I'm just curious, how does this apply to the chemical research project?
To which?
Like, is it chemical research, like we need to do synthesis?
Yes, so we are currently mostly focused on molecular properties, but IBM has a history and has also developed some models for things like retrosynthesis. But think about this more for, I've got a list of desired properties and I want to generate the molecule that fits those properties. One of the cool things that we're looking at is taking these base models and adapting them to say, wait, those, I don't mean just performance properties. I also mean things like safety or sustainability or cost. So how do I use one of these, let's call it a materials foundation model. How do I use it to kind of expand the design criteria for materials and take some of those other important aspects into account early on?
Great. Okay. Well, thank you very much. Thank you for your talk. Thank you for keeping it short and to the point. I do want to do one last shout out for those of you who stuck around. There was a question about, I think the gentleman's gone, but no, about how do we, how could companies perhaps, collaborate maybe on creating their own foundation model or something like that. And while the AI Alliance would certainly like to help along with that, I don't think we have any exact plans for that right now, but we are starting to work on one of the most costly aspects of generating your own model, which is gathering the data and cleaning it up, making sure that you have the rights and the license to that data. It's very expensive to get all of this together, to clean up all that data. Sometimes the compute of that alone can actually cost more than the compute of training the models. And so that is something that we recently have soft launched through the AI Alliance. And if you go to our website and you look under community, you'll see become a contributor. And what we're looking for right now are industries and members of industries that have data that they would like us to consider working with you on to gather and clean up. So it is something that we will be spending a lot of time on. So if you have an idea for something like that, please visit our website or contact me and let us know, and we'd be happy to work with you on that. So other than that, thank you very much for coming. We've really enjoyed it. I hope you did too. And we hope to see you again sometime. Thank you. Oh yeah, stay tuned for more.
That you would announce it.
We don't have a set date.
Everyone stick around if you'd like to know the raffle winner.
Oh, raffle winners.
If you want to last minute enter, please scan this QR code and star Milvis. And I'll give you a minute to do so.
Are you off or are you still?
All right, there's still a last chance to win a prize. And everybody busy with your food. There's a chance to win your prize. Oh, you just scan the QR code and give it a star, and then you automatically enter the lottery. Started?
Oh, yeah.
Just yeah. Yeah. I mean, enter. All right, let's do it.
Okay, let me get those last minute entries. Let me get the last minute entries.
So we got some socks and a lovely Mills t-shirt with the little blue bird on it. It's actually this one.
Yes.
It's entering this lottery pool. Yes.
Yourself on here?
Yeah, third and the
What's your
third.
GitHub name?
Yeah, I'm still copying.
You have done it
1
already.
minute.
You have done it already. You have successfully. Yeah.
Frank.
All right, let's spin the lucky wheel.
Still have 6 more. 1 minute.
So this is pretty much a gold rush.
Two more.
Got 2 more potential lucky winners. Check your name on it. Yeah, it's just one of the name.
Okay, last refresh here.
Maybe next time we'll do vector search on this.
Oh, that's me right there. It's me right there, Super Mojo.
So AI just doesn't automate everything.
Thanks for the patience. Okay, last. Ready?
Woohoo! Okay, we got the mug. Okay, hard to pronounce. Bega. Who is wow, or winner? Yeah, we'll have more winners. Make sure to get your t-shirt and socks at the end. Oh, still the same person? Oh, Trevor Train. Is that the correct way? Who is Trevor? Trevor? Do you have Trevor Train here?
Going once.
Okay, going once. Twice. Deal, we'll skip. Oh. Well, you're just in time. All right, we'll get. Okay, we got 2 lucky winners. Well, if you didn't win the prize, we still have the lovely free stickers with the bird. Just on the desk of the entrance. And also, please come to our unstructured data meetup next time. Thank you, everybody.
So